Good afternoon, everyone. My name is Mansoor from Lepton Software Solutions, and we welcome you all for today's webinar on 5G network planning using 2.5D versus 3D maps. The session will be for 30 minutes, and we will have a Q&A session at the end of the presentation. I would request you all to kindly type your questions and queries in the Q&A window, and we will take them after the presentation is finished. Our speaker for the day is Ms. Sita Gurung. Ms. Sita is the product manager of RF Maps and Map Info at Lepton Software. She has been associated with Lepton for more than 12 years and is a proficient expert in helping telecoms and OEMs with the help of geodata and for network planning, design, and optimization. Now, I would request Ms. Sita to take this session forward with her presentation on the topic of the day. Ms. Sita.
Thanks, Manzil. Hello, everyone, and thank you for joining us today in this webinar. So today's topic is all about 2.5D maps, which is an alternate solution for 5G planning. And we have designed these cost-effective hybrid maps for the projects where we have limited budgets. So I have organized today's presentation as an overview. Today's topic, which is 2.5D maps, and we will talk about various data layers available in this package. And in the end, we will take your queries and we'll try to answer immediately. Else, you can also touch base with us via phone or email. To give you a background about Lepton, we have established ourselves 2 decades ago. And in fact, we have started our journey with map data creation for telecom industry only. And later on, eventually, we have evolved ourselves as location intelligence solution provider. We have a strength of 200 plus employees with data analysts, data engineers, and GIS specialists. And being a location intelligence solution provider, and aside having our own products, we also have our partnership with industry giants like Google. I'm sure everyone knows Google. We are a premium partner for their map and cloud projects. We are the authorized partner for Pitney for their location intelligence products like MapInfo, Spectrum, and Confirm. We are the authorized partner for InfoVista for their planning tools like Planet and Ellipse. And then finally, VIL, Vodafone Idea Limited. We are the strategic partner of VIL here in India. Though a major chunk of our business comes from telecom industry, we do cater other industries as well, like BFSI, FMCG and retail, automotive, logistic, government, insurance, and travel. So if we talk about our own products, I mean, apart from the partnership that we have with the industry giants, we are actually categorizing them as 4 products. To start with, first one is RF map, which will be covered today. Second, network access. It's a web-based telecom-centric product which helps ISPs and operators to inventorize their network and perform various analysis. Third is Smart Market. This is again a web-based location intelligence platform which helps you to understand your current business potentiality, and it also helps you to plan for your business expansion. Then we have Smart Data. So Smart Data is a repository, or you can say a collection of various map data products which can be consumed in our solution like network access and smart market. And it consists of various map data sets like population, administrative boundaries, landmark and POI, road network, etc. I mean, you can name any map data layers, it will be considered as smart data. And we are ready to help you with those maps. So RF map or radio frequency map, that's what we call it. So we basically offer three types of a map data set to our telecom customer, or you can say geodata. Either you call it RF map, radio frequency map, or geodata, whatever suits you. We basically categorize them as 2D map, 3D map, and 2.5D map. And that's what we are going to talk about today, which is 2.5D map. So what is 2.5D map? I mean, how is it different from 2D or 3D data set? So 2.5D is an intermediate solution between 3D and 2D, which provides you the height information for the settlements and obviously with better cost compared to 3D maps. And with current scenario, though we are a bit slow, but we all know that world is moving toward 5G, and 5G requires 3D information or height information to calculate the obstructions, which can have significant impact on wave propagation, right? And though 3D dataset is the best solution, is the best answer for core area where we have dense buildings. However, if you have budget limitation, if you have budget constraint, you can rather opt for clutter height information, which is available in 2.5D map. So rather than investing a huge money in 3D maps, you can go for 2.5D maps, which will have the clutter height information. So that's what we are actually offering, the height information for the clutter dataset. Now let's talk about the various data layers, various information that are available in 2.5D map. So first of all, what will be the resolution? 3D data comes with high resolution of 1 meter or 2 meter, and 2.5D comes with 5 meter resolution. So let's say if you want to go for planning activity for your urban areas or suburban areas or rural areas, you can go for 2.5D dataset. The data layers that are available in this particular package are Clutter, which will have somewhere around 15 to 25 different classes. The classes will vary depending upon the project requirement. It can go from 15 to 25 classes. The accuracy that you will get with this particular package is 5 meter accuracy. Second layer is clutter height. So that's the differentiator here, clutter height. So we are actually assigning or giving the height information to those settlement or buildings that are available in clutter layer. And the accuracy that we are achieving with this particular layer is in between 3 to 5 meter. Then we have DTM. It's obviously it will have MSL value or the height information of bare earth surface. Then finally we have linear vector or 2D vector, which will have different categories of road, water, or railway network. And the accuracy that we are offering is obviously 5 meter. So that's the entire package. We will now see in more details what all these layers are, how Lepton design these layers, and what are the accuracy that we are offering in these individual layers. So let's start with the first layer, which is clutter dataset, or you can also call it as land use. The clutter dataset will be derived from the stereo mono satellite imagery having 5 meter or better resolution. It will have 15 to 25 clutter classes, as I have mentioned. And in fact, with next slides, I'm going to show you the clutter classes, list of clutter classes that we offer with this particular layer. We basically use various image processing algorithm and industry standard processing software to develop this particular layer. And there you have the list of various clutter classes available in this layer. These are for reference only. It can be changed, it can be categorized as per project specification, though I have kept it for a reference only. So as you can see, we are actually categorizing them as number of floors. So we are not going to capture each and every building, but we are going to capture group of buildings with average height information. That's what we are providing here in this particular layer. The second data layer is clutter height, which is actually derived from the previous layer, which is clutter. So after extracting all those information from all those settlement information from from satellite imagery and categorizing them as floor wise, we finally assign them with the height information. So obviously the delineation will be done using the in-house customized tool that we have developed. The height information will be assigned using Lepton in-house tools. And as I have mentioned, individual building footprint will not be part of 2.5D data. So we are basically capturing group of buildings, and this splitting will be done on the basis of average height. That's the information, that's the height information that you are getting in clutter height layer. And with this screenshot, I am actually trying to show you the comparison in between the clutter layer and clutter height. So in my left hand side, the image that I'm showing here is actually 2D view of clutter height, where you can see the different color represent different clutter classes. And in my right hand side, the image that you are seeing here right now is actually the 3D view after the assignment of height information. So that's the comparison between 2D view and 3D view. Both are same data set, it's just the 3D angle and 2D angle of the same data set. And this particular slides or image is actually showing you the actual difference between 2.5D and 3D map. So as we all know, with 3D map, though we have already covered this in previous session, 3D map is actually the actual representation of individual buildings, and not only buildings, but whatever structures that are available on rooftop, you are going to get it as a polygon, as a separate polygon with the separate height information. No doubt, 3D data is best data set if you are going with 5G planning. There's no other answer apart from 3D. But as I have mentioned, if we have budget constraint, we can always go for intermediate or hybrid map, which is 2.5D map. You can actually see the comparison. You are not going to get the superstructures on rooftop. You are not going to get the individual polygon for each and every building in 2.5D. However, you are going to get the height information. That's the difference between 3D map and 2.5D map. And with these two arrows, two red arrows, I basically have tried to show you the comparison between the buildings having superstructures in 3D map and the buildings without any separation in 2.5D clutter height dataset. Apart from these two layers, we do have a DTM layer in our offering with 2.5D map package. So DTM will obviously be the height information for the bare earth surface. The accuracy, the planimetric accuracy that we are offering with this particular layer is in between 3 to 5 meter, and the altimetric accuracy will be plus minus 5 meters. So it will be a raster file, and it will comes along with this clutter height and clutter layer. And then finally we have 2.5D geodata set, linear vector. So with linear vector, the input will be satellite imagery only, the mono satellite imagery. And the information that you are going to get will be point, line, or polygon feature. Those objects will be categorized as various road categories or water bodies or boundaries, and it will be available in vector format. The accuracy that you are going to get with this, or the planimetric accuracy that you will be getting with this layer, will be in between 3 to 5 meter. So that's all for today's session. I know this is very short session, but I basically tried to cover up the various information that you can get with 2.5D map. We will proceed with your queries, and before that I am trying to show you the client logos that is there in this particular slide. As you can see, the distribution of our client is across all industries. You can find telecom companies, you can find banking sector or FMCG, retail. So we have these huge list of customer, but we actually try to showcase customer from various industries. And that's all for today's session. We can proceed with your questions, with your queries. You can put all your queries in Q&A window. So let me just go through your queries. So the first one that I have got is, why should I use 3D geodata for 5G network? So as you know, 3D geodata is, what is 5G network? So the placement of your sites is actually very crucial in 5G network planning, right? And if you place your sites very tightly, you will have to consider all the obstructions, including your walls, including your vegetation, including your buildings. So that's why 3D geodata is important for 5G network. Though today's topic was 2.5D, but we have already covered this 3D geodata session. We will try to repeat that session in later stage. I hope I have answered your query. What is 5G planning? Why is it different from other generation? So I guess you can, I will not be in a position to answer your query. Maybe you can look for various reference that are available over net. Maybe that will answer your queries or questions that is there regarding the various differences in between those generations. We will have queries regarding geodata set in this session. These planning is only for building, etc. Can we use these for vehicle identification? So so far we have only captured buildings vegetations, and the structures which are having 5 into 5, or I would say 25 square meter area. So we haven't in fact captured any 3D information for vehicle, though we can discuss it. We can have a look on the aspects for vehicle identification aspect in this particular data gathering. Can we get more accuracy like cm within meter? If you want to go with better accuracy, I'll suggest to opt with 3D dataset. However, with 3D dataset that will be derived from stereo satellite imagery, you are going to get sub-meter accuracy. You can also go for 3D map dataset generated from aerial photographs, which will have accuracy in centimeters. Can this planning is used to identify tunnel on roads? We did a project with similar kind of specification where we actually need to identify the tunnels that are overground, as well as the tunnel that are going underground. So yes, we can actually capture those information. Can you please demonstrate the 2.5D map, like how we can see the height of building? Is it any process? So I have got this query. Maybe we can touch base and have a one-on-one session. I can showcase the live data set in that particular meeting. We'll connect after we finish the session. How 2.5D and 3D maps are created? What is the difference in the process? Why 2.5D and 3D data required? So as I have mentioned, 2.5D or 3D or whatever data which is having height information is required for 5G planning. And the input sources are different for 2.5D and 3D maps, as well as the process that we use to generate these two maps are very much different. 3D map can help in GIS platform. I'm really very sorry, but I couldn't understand this question. 3D map can help in GIS platform. So 3D map is nothing but GIS dataset. So if I have to answer your query, a GIS platform is required to open to create 3D maps. Using this, can we make any LOS feasibility? What about other calculation like link budget? So yes, LOS, you can do LOS calculation since we are providing the height information in 2.5D dataset. You can use this particular dataset in LOS feasibility calculation. What is the minimum area required for a 2.5D or 3D map slice? So minimum area can be discussed separately. It depends upon the budget and the project specification. So if you have any query, maybe we can interact in one-on-one session. How this will help in fiber planning? So for fiber planning, you would actually require, if I have understood correctly, I'm sure you are not asking for map dataset. So for fiber planning, we have a separate product called, or separate solution called network access. There's a dedicated team available for that particular product. So maybe our marketing team can help you to connect with those, with that particular team, and they will answer your query. Which algorithm can be used to deploy 5G network cells? So I would be able to answer your query regarding the geodata part. For the technology part, we can connect you to the dedicated team. In 2.5D maps with the clutter height layer, is the height value an average height per clutter type? Yes, that's correct. That's what we are doing. So it's the height information is not for individual building. It's actually the average height per clutter type. Mm, 2.5D. As fiber needs to dig roots. So, okay, in terms of map, if you will have to do fiber planning, the map dataset that is suitable for you will be land cover, sorry, land-based map, which will have the actual representation of Earth, having your plot boundaries, building boundaries, road as polygon, footpath information. So you would need to go with 1:1K scale land-based map for fiber planning, not 2.5D map. Please can you repeat difference between 2.5D clutter layer and clutter height? So clutter will have character information like categorization, dense urban with 0 to 5 floor, suburban with maybe 5 to sorry yeah 5 to 10 floor information. However, clutter height will have numeric value, integer value, so it will be a grid file. So that's the difference. Clutter layer will have character information, clutter height will have the numeric information or the height information. Can we get accuracy in number of floors in a particular building or house? Can we get the accuracy in number of floors in a particular building house? As I have mentioned, so the information that we are providing in 2.5D is the averaged information. So be it your floor or be it the height information, it will be the average value. That's why we are keeping the category as 0 to 5, 5 to 10. So whatever buildings that are available, let's say if we have one floor building, two floor building, we will count it as a single category. So that's, I mean, average height information will be, or average floor information will be available. If you want to go with the individual building information, you'll have to go with 3D layer. What is the different map resolution available for 2D and 2.5D map? So with 2.5D map, right now we are only offering 5 meter resolution, since that's the best resolution that we can offer with 2.5D map. And for 2D map, resolution may vary from 5 meter to 10 to 20 to 50 to 100 meter. It depends upon project requirement, or it depends upon the planning that you are going to do. If you want to do city level planning, you can go with 5 meter or 10 meter resolution, or if you are going with regional level planning, you can go with 20, 50 or 100 meter. Does your data contain candidate position for 5G cell placement? So we are only providing the map data layer. So if you want to do any planning related activity, I'm sure you'll have to look for in your planning tool. Can you please demonstrate the 2.5D map, like how we can see the height of building? Is it any process? It's just the 3D view of the clutter height layer. So it's actually your software. If your software is having that capability, you can showcase it as 3D view, provided your data is having height information. Where 2.5D data used and where 3D data used. So I would say 3D data will be used where you would want to attain maximum accuracy, like indoor planning, or the core area where you have very dense skyscraper buildings. For those area, you can go for 3D dataset. But apart from those area, if you want to do 5G planning for outdoor area, like urban area or metropolitan area or suburban area, you can go with 2.5D map. What is the minimum angle to capture the proper view? I'm really sorry, I didn't understand your query. What is the minimum angle to capture the proper view? We are not capturing. Is it related to satellite imagery? Because we are actually deriving or creating data set from satellite imagery. We are not capturing any image. How this will be help in fiber planning? I guess I have got this repeated. For fiber planning, you need to go with 1:1K land-based map. Do you have Mumbai data set? We do have it available data available for entire India. In fact, we have the various data sets available for 150 plus countries, plus 2000 or 3000 cities in those countries. So the resolution and the data packages vary. So you can check with us separately. We will be able to share you the information if you want to go with 2.5D map for Mumbai, 2D map for Mumbai, or 3D map for Mumbai. Which algorithm can be used to deploy 5G network cells? I'm really sorry, I won't be able to answer your query. I can answer your query regarding the geodata part. For technology part, either you can refer the available resources or our marketing team can connect you to the respective team. Can I get the sample for Mumbai Geotar? Sure, we can share that. Mansur is going to send you all the thank you note for this session. Probably you can submit your query, your request regarding sample dataset in that particular mail. Is it possible to get 2.5D at data at 50 meter or 100 meter? There will be no use if you want to go with 50-meter resolution 2.5D dataset. As I have mentioned, right now the best suited product that we are offering is at 5-meter resolution. Pan India 3D map is available with Lepton. The 3D map availability for Pan India is, I would say, no. We have availability for limited cities. Obviously, no one is going to go with 3D map for rural area, but yes, for urban areas, we do have 3D map available for India. Is it possible to get 2.5D data at 50 meter? Or I have already answered this question. It can help on roadside for movable vehicles. So, movable vehicle, the data set that we are creating here is not for movable objects. We are creating map data set for static objects. What is the major difference between 2.5D and 3D planning? One point where we can identify which one to use. Probably you can go with the sample data set that we offer and evaluate our data set, and you will get to know the difference between 2.5D and 3D. That will be the best solution. Can we access this maps on phone? So to access your maps on phone, it's actually the application where you are going to consume these maps. If your planning tool can be opened in phones, yes, you can open these maps. These are flat files only. You will only have to install your application, your software in phones and access these maps. What is the cost for 3D map of Mumbai dataset? So any queries regarding to the commercial, we can discuss 101. It will vary depending upon the project requirement and the budget. Can I get the sample of Mumbai geodata? Yes, you can. Can we integrate 3D map with ITMS platform? If your platform supports geodata sets, any industry in that standard geodata format, you can. Can you please share sample data of 2.5D and 3D? Yes, we are going to share the sample. You can drop us a mail and we will answer with the samples. Do you have a map density for distribution? I'm really sorry, I didn't get this query. Do you have a map for density distribution? Okay, population, yes, we have. I mean, population distribution is, though the source for any population data set is census. The additional activity that we are doing here in our R&D center is to project those population at lower level, let's say 500 to 500 grid. So yes, population data is available. And if you want to go with Indian territory, the strategic partnership that we have with VIL is actually for the population data set only, or the subscriber data set. So yeah, we can discuss it separately. We do have very detailed population density information for Indian region, and for other region we will have to derive it. We'll have, first of all, we'll have to source it from local census agency, and then we'll project it to latest vintage, as well as aggregate it to smaller granularity. Can you share sample? Okay, for Chennai, yes. For any request regarding sample, you can touch base our marketing team and you can put all your queries. We will be happy to share those sample data set. Maybe you can just evaluate those data set and share the feedback with us. Can you share sample demo and data set document? Sure, definitely we can.
Thank you, Ms. Sita, for the insightful presentation and answering the queries from our attendees. I would like to ask the attendees if they have any other further questions for the session, or we may go ahead and close the session for the day. Also, since we have seen that there are a lot of queries requesting for a demo and the data set, so I have mentioned the mail ID, which is there also on your screen, that is marketing@leptonsoftware.com. Please write in those requests for your demo or your dataset queries on those. Send it to us at marketing@leptonsoftware.com, and we will connect you with the concerned technical person who can provide you the demo or the dataset examples. Any further queries that we have, or can we move ahead? Okay, I think there are no further questions. So I would again like to thank Ms. Sita for the insightful presentation. Thank you all the attendees for joining us today for the session. I would also request you to kindly fill up a feedback form for the link I am sending you on the same chat window, so that we can improve our sessions in future. Thank you very much. Looking forward to you for our next webinar on RFMap Smart Data Demo on 7th May, that is on Thursday. Thank you very much. Goodbye. Have a good day.